Hey there, fellow philosophy enthusiasts. Ever find yourself pondering how logic, shapes not just our philosophical musings, but things like economics, even our understanding of the world around us?
Well, get ready to dive deep because today we're exploring the fascinating world of William Stanley Jevons.
A 19th century thinker who really blurred the lines between economics and philosophy, leaving behind insights that still resonate with anyone, really anyone interested in how we think.
And to guide our exploration, we'll be drawing primarily from the Stanford Encyclopedia of Philosophy's entry on Jevons.
Yeah, consider this your express lane to understanding this complex figure. We'll be distilling down his core ideas across a whole bunch of fields.
Logic, philosophy of science, philosophy of mathematics, and even philosophy of
What
economics.
we really want to dig into is how looking through a philosophical lens helps us understand Jevons' work and the impact it's had.
Think of this as your philosophical map to navigate his ideas.
So before we get too far, let's do a quick intro to the man himself. William Stanley Jevons, born in Liverpool back in 1835.
Came from a family with a strong intellectual tradition, I'd say. Studied chemistry, and very important for our discussion, logic under the well-known Augustus de Morgan at University College London.
He even spent some time in Australia working as an assayer, but his mind never really stopped exploring, from railway policy to even meteorology.
And after he returned to get his degree, the 1860s were a whirlwind of breakthroughs for him. We know from his diaries he had this, aha moment about economic value and made huge strides in logic with his idea of the substitution of similars.
From there, his academic career really took off. He landed positions at Owens College, Manchester, and eventually got a professorship back at UCL.
And get this, he won a gold medal in not one, but 5 subjects: logic, moral philosophy, political philosophy, history of philosophy, and political economy.
Talk about an interdisciplinary mind. Tragically, though, his life was cut short in 1882 in a drowning accident.
Now, being philosophers, I think we're naturally drawn to the foundational stuff. So let's start with what Jevons called the laws of thought.
Right, and for him, these weren't just helpful guidelines or anything. He considered them fundamental, objective, existing in the nature of thought and things.
Exactly, and this is where it gets really interesting for us, thinking about the basis of thought itself. He argued these laws are so essential that even trying to disprove them uses them.
You can't escape them, can you?
Nope. He pointed to the law of identity A equals A, pretty straightforward. Then there's the law of contradiction, A equals 0. Essentially, something and its opposite can't both be true. And finally, the law of duality, also known as the excluded middle, A equals AB plus not AB.
Meaning any A is either B or not B.
Right. To him, these formed the bedrock of all scientific inquiry and logical reasoning. He called them the prior conditions of all thought and all knowledge.
But even within these seemingly self-evident laws, he found a bit of a head-scratcher, especially with the concept of sameness, or identity.
He questioned what exactly makes something sufficiently similar for a substitution to work in a logical argument.
I can see how that gets tricky.
He used the analogy of a sample representing a whole batch of something, like, a small scoop of coffee beans representing a whole bag. If the sample's a perfect match, you can make reliable inferences. But the problem, as he pointed out, is figuring out what perfect representation even means in practice.
That leads us straight to his big idea about inference, doesn't it? The substitution of similars.
Precisely. He believed all knowledge starts with our senses, making it fundamentally inductive. Deduction to him was kind of like going in reverse, but both rely on this core principle, recognizing and substituting things that are alike in the right ways.
So for our philosopher brains here, Jevons is saying that to understand how we move from seeing a few examples to grasping a bigger concept.
We have to look at how we identify that fundamental likeness, not just superficial similarity, but the underlying traits that let us generalize.
All right, let's move on to logic itself. Jevons was super interested in making a clear link between logic and mathematics, even hoping to build math up from logic.
What's fascinating from a philosophical standpoint is that he tried to create a formal system of logic using mathematical symbols. He used capital letters for terms, small italics for their opposites.
The equal sign for identity, naturally.
He even invented a symbol to represent any general relationship between terms.
And if you're thinking his definition of a term was pretty broad, you'd be right.
A term to him was any name or any combination of names and words describing the qualities and circumstances of a thing.
Qualities and circumstances. That's pretty wide-ranging.
Right. He also made this distinction between the extent of a term, the things it applies to, and its intent, the qualities it implies.
So dog, the extent would be every single dog in the world.
Exactly. And the intent would be all the things that make something a dog: furry, four-legged, barks, the drill.
But the more specific you get with the qualities, the fewer things fit the description.
Precisely. He then categorized terms as abstract, like wisdom, the quality itself, and substantial, like a wise person, a thing with that quality.
Got it. But he also had these special laws for combining terms, right?
The law of simplicity, which basically says combining a term with itself doesn't change anything. A equals AA equals AAA, and so on.
Kind of like saying a dog is a dog is a dog.
And the law of commutativeness, which means the order you combine terms in doesn't matter. AB equals BA.
So a big red ball is the same as a red big ball.
Now, when it came to propositions, Jevons saw them as statements of identity under certain conditions.
So simple propositions like A equals B, he used the equal sign to show that connection.
But he wasn't a fan of using some, that indeterminate adjective,
So instead of all A or some B, he preferred A equals AB.
Showing all of A is identical to a part of B. He really wanted to be precise, and he went on to lay out all these different forms of direct inference within his system.
From the super basic to the more complex ones involving simple and partial identities.
And get this, he even showed how the classic Aristotelian syllogisms fit perfectly within his framework.
He even tackled disjunctive propositions, the ones that give you options.
Right, and for that, he used a special symbol to show non-exclusive alternatives, like coffee or tea or both. It's different from how we use or sometimes, where it can mean you have to choose one or the other.
So I'm guessing he saw some connections between logic and math here.
Definitely. He even pointed out this imperfect analogy where A or A equals A, which is kind of like how in math, A plus A equals 2A. Then there's the idea of indirect inference, which he thought was super important.
The whole prove something by showing it can't be anything else thing.
Exactly. And he used his law of duality to show how you could derive the contrapositive of a statement. Like, if A equals AB, then not B equals not B and not A.
I'm starting to see how this all gets pretty complex, especially when you add more and more terms.
And absolutely. And Jevons knew that. He came up with the logical alphabet, which is basically all the possible combinations you can make with a set of terms. But the problem is, the more terms you have, the more combinations you get. It quickly becomes too much to handle manually.
Sounds like a headache waiting to happen.
So to solve that, he invented some early computational tools, the logical slate and the logical abacus. These were seriously innovative for their time.
Talk about a logic pioneer. Lastly, for logic, he really grappled with induction. He saw it as way more intricate than deduction and, the basis of all our empirical knowledge.
He recognized that induction relies on rules of thumb and trial and error. He even laid out specific ways to induce simple and partial identities. But he didn't shy away from the problem of induction either.
The whole question of how we can justify saying something's true in general just because we've seen it happen a few times.
Right, and he thought probability theory might be a way to tackle that inherent uncertainty.
Which brings us to his philosophy of mathematics, probability, and statistics. Jevons believed math should ultimately be built on logic, which is interesting when you compare it to someone like Boole.
It's a fascinating philosophical point. He tried to define number by counting distinct units in space or time. He even suggested giving each identical unit its own special name based on where it was in space.
So like if you had a bunch of coins, each one would get its own label based on its position.
Exactly. But as Frege later pointed out, this runs into problems. If you're using the same symbol for identical units, they can't really be distinct in the way Jevons needed for his system to work.
So Frege was saying Jevons' idea was too tied to physical things when numbers are more abstract.
Exactly. Frege argued that numbers are properties of sets, not just physical objects. So while Jevons was trying to ground math in a more concrete kind of logic, Frege thought he missed the mark.
So even though he built this whole logical system, its application to math didn't really stick, except maybe in teaching.
Pretty much. While his logic textbooks, like Elementary Lessons in Logic, were really popular, his foundational work on math didn't really catch on. But that's not the whole story, of course.
Right, we can't forget his contributions to probability and statistics.
He was a true pioneer in bringing statistical and econometric methods to the social sciences, one of the first to really use quantitative tools to study economic stuff.
Like his 1863 work on the depreciation of gold, right?
Exactly. In A Serious Fall in the Value of Gold, he looked at the impact of the gold rushes in Australia and California. He used index numbers, calculated with the geometric mean, arguing this would balance out what he called multiplicative disturbances, though, to be fair, that specific idea hasn't held up empirically.
But the way he used probability to try and distinguish cause and effect from just coincidence was pretty innovative for its time.
Absolutely. And his application of the method of least squares, even with the mathematical limitations of the time, was groundbreaking. He even made this interesting distinction between different kinds of means or averages,
Right, he borrowed from Quetelet's work.
and differentiated a mean as an approximation of a real value from an average or fictitious mean, which is just a simple arithmetic average.
So like the average height of everyone in a room versus the average height of all humans?
Exactly. He thought the fictitious mean was really useful for summarizing tons of information into a single number, like total consumption versus average consumption.
And he even recognized that people are all different, and that averages still tell us something useful.
Yeah, he got that individual behavior varies, but in large groups, these quirks kind of cancel each other out, creating this idea of a typical consumer. He saw how helpful averages were for business and trade, but also cautioned that you can't forget about individual differences when making policy decisions.
And that's where character comes in, this idea that character could bridge the gap between general trends and individual quirks.
Now, when it comes to his philosophy of economics, Jevons is often portrayed as a hardcore mathematical deductive economist.
And at first glance, that seems about right.
He did seem to build his idea of market prices from what he called the mechanics of utility and self-interest. He envisioned markets with perfectly rational, forward-thinking people who had all the information they needed.
But he acknowledged that this perfect rationality wasn't always the case in real life, didn't he?
He did. He believed that the ability to plan ahead and make decisions based on future outcomes varied depending on factors like intelligence, character, and even the overall progress of society.
So character wasn't just some random side note. It played a real role in his economic thinking.
While he often worked with this model of representative individuals who all had the same character, he knew real people were more complicated. He believed these deviations from the ideal were partly due to differences in character, which he saw as influencing things like work ethic and how far ahead people planned.
So to sum up our deep dive into Jevons, we've seen a thinker who tried to make logic mathematical, pioneered the use of stats in economics, had some really insightful ideas about how we learn and understand, and really grappled with the relationship between abstract theories and how people actually behave.
And for you, our philosopher listener, we'd love to hear your thoughts. How do you think Jevons' interdisciplinary approach, his attempts to find a solid foundation for knowledge, and his engagement with the messy reality of human behavior speak to your own philosophical journey?
What resonates with you about his work trying to connect logic, math, and the social sciences?
Here's a final thought to ponder. Jevons was really ambitious, trying to create this unified understanding of thought, reality, and the social world.
So, knowing all we know now, how would you, as a modern philosopher, assess his success? Did he achieve his goal? Where did he fall short?
And how do you think the advancements in logic, philosophy of science, and social sciences since his time affect how we view his contributions?
We encourage you to delve further into the Stanford Encyclopedia of Philosophy entry on Jevons and any other related philosophical works that pique your interest. Keep that philosophical exploration going.
Until next time.
Happy pondering.